Hello everybody, I'm alisharifi, a Master of Science in Road and Transportation. Through tutorial videos, I'm going to share my knowledge and my experience designing accurate intersections and interchanges of different types, both geometric and operational wise, which I've been practicing for nearly 20 years now. I also try to show you how the model and design steel connections in Idea Statica, which I found very interesting and useful. Well, definitely as a whole, not their field of civil engineering, but what they've got in common is that they're both very important area within a road or a structure. All right, now I'll appreciate if you follow us on Instagram, Telegram, or LinkedIn. So as soon as a video is released, you'll notice and you'll get the link to watch the video on our channel in YouTube. Alright, the video you're watching at this very moment is the first part on designing modern roundabouts, which in the following discussion we will refer to as just roundabout. In the first section, which is covered in this video, we will talk about the features that makes a roundabout different from rotaries. Also, we will discuss the different categories of roundabouts and the tips that should be considered in designing of each type. In the second section, we will go about geometric design of roundabouts. The subjects are how to determine the width and the radius of different elements and consideration on position and alignment approaches. Also, a vital part how to draw the fastest path and check the speed consistency between consecutive reverse curves and also between different movements within the roundabout. It's also important to make sure there are enough clear distances along some different directions so a driver is given enough time to perceive and react to a conflicting vehicle on its path. Safety wise, it's important and it's the subject to the third section, checking side distances. In the last section, we will discuss methods for estimating Q and delay of each leg and how to use these measures to determine the level of service of the intersection under consideration. The information presented in these sections are mostly taken from NCHRP Report 672, second edition. We will also refer to informational guide on roundabouts of Federal Highway Administration and to get more detailed information for designing some special parts like alignment of approaches in rural areas. We'll use some part of Facilities Development Manual of Wisconsin. And also to see how determine the needed width for a design vehicle when they're negotiating a curve. We also use some part of the Green Book, 7th edition. All right, let's get us started. The first step in introduction of a roundabout is to make sure we already know the distinguishing features that makes a roundabout different from rotaries. So let's first discuss the distinguishing features that makes a circular intersection characterized as being a roundabout or a rotary. It's important to notice it's not like we're gonna make a comparison between two type of common circular intersections. Actually, rotaries are old style of circular intersections and they were common to the United States prior to 1960s, and they're not an option anymore. But the point is, since internationally the experience with rotaries are negative, we don't mix them up and take a roundabout for a rotary. All right, let's start with rotaries and their distinguishing features. Rotaries are known for their large circles, and it's for a reason, as it's being shown entering and circulating traffic go through a weaving section as they negotiate the circle. So the length between adjacent legs has to be long enough to give the drivers enough time to perform their maneuver. At the very least, the speed that entering and circulating movements will be operating at could be 20 to 30 mile per hour, which is optimistic due to geometric of rotaries. Given this range of speed, the weaving length comes to like 100 to 160 feet. If take into account the effect of higher speed and or higher volumes and the weaving lengths, the needed length for weaving section increases, which normally happens in practice, sometimes even up to 300 feet. Now, the longer this length is needed to be, the longer this radius should be. And given these figures, it's no wonder why rotaries are known for their large circles. To get a rough estimate of the size of a small rotary, suppose this is a rotary within a urban area, then the entry radius, this one, could be as large as 65 feet according to the geometric principles of designing rotaries, and the center island radius should be at least 30% larger than the entry radius, so this radius would be like 85 to 100 feet. Now we can get an idea how larger are rotaries than roundabouts. The largest type of roundabouts has a radius of 100 feet, including its central island and its circulatory roadway, which means the largest roundabout with its circulatory roadway can be fitted within just the central island of kind of smallest rotary. In practice, rotaries inscribed diameters are normally of the size of 300 feet. Besides its negative effects on performance of intersections, the construction and maintenance of an intersection at these dimensions is expensive, especially in urban area that there are lots of constraints on right of way. All right, let's move on to the next distinguishing feature of rotaries. As we just mentioned, for some reasons, rotaries have got large circles. The larger this radius is, the higher speed the circulating traffic will adopt. Entering traffic also has got the chance to gain higher speed on this length if they're not entering the circle at higher speed at the first place due to the large diameter of rotaries. So we've already got weaving maneuver, and now the vehicles that are involved are operating at high speed, which make it more challenging, and the consequence is frequent and even sometimes severe crashes, especially at higher volumes. The third and maybe the last distinguishing feature is entering traffic has got priority. It is actually the right hand rule. Since circulating traffic has got the entering traffic on its right, it must give priority to the entering traffic. It's not just a rule to easily make it otherwise, it's also geometry. Due to the large dimensions of rotaries, entering traffic can easily enter the circle, and it encourages them to not to give priority to circulating traffic. Given this feature, entering traffic will outnumber the exiting traffic. So during peak hours, the rotary will experience congestion, and if Q is pulled back, it can lock up the adjacent leg and maybe even the whole legs. Due to these features and their consequences, rotaries have acquired a reputation for being a kind of circular intersection with frequent and severe crashes and experiencing congestion and even locking up during peak hours, which caused rotaries falling out of favor in the United States in the mid 1950s. Given the issues associated with the performance of rotaries, in 1966, in United Kingdom, roundabouts were developed to improve both safety and operational performance of circular intersections. So it's no wonder if the features of roundabouts are opposite the rotaries ones. Let's see what changes they have made to put it right. Uh, First to mention is that the geometry of roundabouts are developed so that speed into, through, and exiting the roundabout is controlled and consistent. As a driver approaches a roundabout, there are three important points that force the driver to follow a path consists of three consecutive reverse curves with short tangents in between. This is called the fastest path, and we have a lot to do with it in the next section. There we'll discuss how to draw and check the fastest path. But here we're just gonna talk about its effect on the performance of roundabouts, which becomes a feature of it. If a circular intersection is to be characterized as a roundabout, this deflection has to be sharp enough to induce a speed which meets the criteria for modern roundabouts, normally less than 15 to 30 mile per hour, depends on the category of roundabout. It is necessary, but not enough. The speed between consecutive curves and also between conflicting movements has to be consistent. Normally, a maximum difference of 10 mile per hour is accepted. So if a circular intersection is designed geometrically based on the criteria of roundabouts, then unlike the rotaries, the vehicle will enter and negotiate the roundabout at a slow and controlled speed. All right, uh, let's move on to the next feature. Unlike the rotaries, roundabouts have got small circles, and that's for two reasons. First, entering and circulating traffic cross rather than going through a weaving maneuver. So there is no need to provide a length to accommodate the weaving section like we did in designing rotaries. Second, as we just mentioned, the speed of different movements is controlled by geometry of roundabouts. Sonora Island radius uh, has to be not too small, but small enough to induce uh, circulating traffic to operate at a controlled speed. But how the roundabout geometry manage this crossing maneuver safely? Uh, the answer is since entering and circulating traffic are forced by geometry of roundabouts to operate at low and consistent speed, the crossing maneuver will be safe. It also has something to do with providing adequate uh, side distances that we will discuss in third section. It's important to notice that even with the small size of circles, there are circumstances the desired crossing maneuver turns into a weaving maneuver. For example, when the angle between adjacent leg is far bigger than 90 degrees. Well, it's the subject the next section, but for instance, realignment of one approach, as you can see in these pictures, can address this issue. All right. Again, unlike the rotaries, entering traffic must give priority to circulating traffic. It's a rule, and also it's induced by geometry of roundabout. But how? As we mentioned a few minutes ago, due to this deflection, entering speed is controlled and consistent with the circulating speed, which means that they're kind of operating at almost the same speed. Since the entering traffic has to cross the circulating traffic path to enter the circle, and they're operating at almost the same speed, it makes it difficult for entering traffic to keep the priority, and also it gives the circulating traffic enough courage to grab the priority. The consequences is entering movement won't be able to enter the circle till there is a gap of sufficient length between circulating traffic, which prevents the circle from locking up. Given these features and their effects on safety and operational performance, roundabouts are expected to improve the safety and operational performance of the uh, intersection as long as the volume are below the capacity. Uh, so it shouldn't be an odd think if we see they're turning a rotary like this into a roundabout, as you can see in this picture. It also kind of shows how big our rotary is compared to roundabouts. Of course, it's a big rotary and kind of small roundabout. It's not the subject to this video to compare roundabouts with other conventional type of intersection, but since the roundabouts control the speed by their geometry, no matter it's peak volume hours or low volume hours, they're generally safer than other type of at-grade intersections like signalized intersection, which the traffic signal goes off during the low volume hours. Of course, as long as the volume can be handled by the roundabout. Also, generally, roundabouts have more capacity than stop controlled intersection, since the entering traffic needs uh, smaller gaps uh, in between movements with a higher priority. We'll talk about this in more details in the last section. All right, now that we know distinguishing features between roundabouts and rotaries, let's start discussing different categories of roundabouts. Based on size and some special features, roundabouts can be separated into three categories. The smallest one, mini roundabout, the modest size, single lane roundabout that, as its name represents, just one lane is designated to each movement, and the largest one, multi-lane roundabout, which is normally a two-lane roundabout and under some consideration, sometimes a three-lane roundabout. Let's start with the smallest one. Many roundabouts have got a distinguishing feature. The, the Sonora Island is fully transversable. And of course, that's for a reason. Many roundabouts are that small in size that they can't accommodate the whole width of large vehicles inside their circulatory roadway, and the real pass of large vehicles, or sometimes the whole pass of larger vehicles, has to encroach the Sonora Island. So the Sonora Island has to be fully transversable. I believe this animation makes it clear. As you can see, the rear wheel pass of this semi-trailer encroach the Sonora Island. Depends on the size of mini roundabout. It may even makes its left turn completely over the Sonora Island. Some of the most criteria that should be considered in designing mini roundabouts are the environment around the roundabout, maximum allowable entry speed, the size of inscribed circle diameter, and consideration related to Sonora Island treatments and ADT. Environment-wise, many roundabouts are recommended for urban area with approaching a speed less than 30 mile per hour, and where there isn't enough right of way needed for a single lane roundabout. Given this recommendation, many roundabouts are adequate for intersection of local or collector streets, Uh, Given their small sizes, normally there is no worries about right of way, and they can be replaced with other type of traffic calming methods like speed bumps. When checking the fastest pass, the deflection in entry pass should be enough to force entering traffic operate at a speed below 15 mile per hour. The distance across the circle inscribed by the other edge is between 45 to 80 feet. This means this radius is at the most 40 feet, which is smaller than other radius of most large vehicles when they're making a left turn, and that's why the Sonora Island of many roundabouts are fully transversable. This slope is normally 3 to 4%, and once this height reaches 5 inches, the rest of the Sonora Island will be flat. We'll talk more on this in the next section. Average daily service volumes on full leg, below which many roundabout is expected to operate without needing for a more detailed capacity analysis, is approximately up to 15,000 vehicles per day. And this will be the subject to the third section to talk about it more and discuss it in detail. All right, but what about single lane roundabouts? Single lane roundabouts has got a special feature too, and it's this transversable strip around the Sunroad Island, the apron. There is a reason behind this transversable strip around the Sunroad Island, and it's single lane roundabouts are large enough to accommodate the outer radius of large vehicles when they're making a left turn. But especially in urban areas, if we make their circulatory roadways wide enough to accommodate the whole width needed for large vehicles, then the Sonora Island will get too small to dictate enough deflection uh, for entering traffic to slow down. Let's make a comparison. Uh, as we mentioned previously in this video, as a driver approaches a roundabout, there are three points that form its path through the roundabout. So this deflection in entering path will achieve. Now, suppose we add the apron width to the circulatory roadway width. Pave them both with asphalt, for example. Now, the approaching traffic will consider this point for passing through the roundabout, uh, and the entry deflection will decrease. If the speed corresponding with this flatter circle is higher than allowable speed, which is normally 20 to 25 mile per hour, then we must introduce the apron. But what happens to a larger vehicle making a left turn within the roundabout? This picture demonstrates how the roundabout handle it. The rear wheel pass will climb over the transversal apron, while the edge of apron dictate enough deflection to entering traffic, especially passenger cars. All right, now the criteria to be considered in designing single lane roundabouts. First, environments. Uh, Single lane roundabouts can be introduced for both urban and rural areas. Of course, there are some consideration for rural areas, besides the attentions that should be paid to visibility. The alignment of approaches are also important. As you can see in this picture, first the approaching traffic is shifted to the right, then left prior to the entering deflection. Uh, it's a matter of the second section, but the general idea of this alignment is to slow down approaching traffic step by step, normally 8 miles per hour in each step, so it reaches the roundabout at a speed of below 30 miles per hour. Otherwise, the driver could lose the control of the vehicle and end up rolling over, running off the circulatory roadway, or colliding with Sonora Island. The fastest pass should be checked to make sure this deflection prior to entry force entering traffic adopt a speed of maximum 20 miles per hour in urban area and 25 miles per hour in rural area, and the distance across the circle inscribed by outer edge is of size of 100 to 130 feet for urban area and 115 to 130 for rural area. As we just discussed, single lane roundabouts normally have a transversable apron to accommodate the width of turning large vehicles. Uh, this slope is normally 3 to 4%. And how wide should the apron be? We'll discuss this in the next section using AutoTurn software. Average daily service volume and full leg below which a single roundabout is expected to operate without needing to go through a detailed analysis of capacity is approximately up to 25,000 vehicles per day. As a rule of thumb, as long as the sum of entering and conflicting volume on each leg is less than 1200 vehicles per hour, the single lane roundabouts are expected to be able to handle it. And finally, the last category, the largest one and also the hardest one to design, multi-lane roundabouts. It's kind of an art of compromising when we're designing these category of roundabouts. As now we know, the alignment of right hand side of entry and Sonora Island should dictate enough deflection to entering traffic paths to make them slow down. But if we place it too close to the entry, then the driver won't have enough time to change its path so not to end up on the wrong lane in the circle in presence of adjacent traffic. And if we put this point too far from the entry, then getting enough deflection for to make a balance between the needs of speed control and adequate alignment of natural pests. There are two methods to address this issue, and we will discuss them in the next section. All right, like the single lane roundabout, multi-lane roundabouts are appropriate for both urban and rural areas, and of course, some consideration also apply for uh, alignment of approaches in rural areas. When checking the fastest path, the deflection should be sharp enough uh, to force entering traffic adopt a speed of less than 25 miles per hour in urban area and 30 miles per hour in rural areas. Uh, Inscribe circle diameter. This diameter ranges from 150 to 180 feet in urban area and from 180 to 200 feet in rural area. Given the diameters of these sizes, normally multi-lane roundabout do not need an apron. And average daily service volumes on four legs, below which a multi-lane roundabout is expected to operate without needing for more detailed analysis of capacity, is approximately up to 45,000 vehicles per day. As a rule of thumb, as long as the sum of entering and conflicting volumes on each leg is below 1900 vehicles per hour, multi-lane roundabouts are able to handle it. All right, now we're done with the first section, and in the next section, we will go about the geometric design of roundabouts. As soon as the next video is released, I'll put the link in the Instagram, Telegram, and LinkedIn of these addresses, and your comments will be appreciated. Thanks for watching. Hoping it was worth watching. I say goodbye for now.